Hello guys, welcome to our Backbencher Studies channel. And today we are learning the important rules which will be very useful in simplifying a complex block diagram techniques. And a complex block diagram can be simplified into a simple uh, a closed loop or open loop transfer function effectively with the help of these rules. And we have already saw three of them in our last class. We had saw this series kind of thing which will give an effective transfer function and parallel kind of thing which will give an effective transfer function. And if we have this closed loop system, we can have this effective transfer function. And coming to rule 4, shifting of takeoff point after a block. So we have a takeoff point which is after this block G, and we need to shift this takeoff point over to here before a takeoff because before a block. So how we do that? So after shifting, we have this effective picture. So we have shifted this takeoff point over here. So now we have this. So forgot this thing. We will shortly explain how this one is multiplied with gain G. So we have this input signal R, and we have which is being fed into this block G. So we have the output, which is nothing but the G multiplied with R, and the takeoff point means it will give an output which is same as this point. So this point is having an output R into G. So the takeoff point is needed to be R into G. So if we shift this or if we move this takeoff point to here before the block, the takeoff point shifting before the block, we have this. So if we take this signal, we have only R. So the signal here coming will be R. But we should have RG over here. So to compensate with this gain G, we added another block G, which is of same gain which we surpassed before. So thereby giving us this effective takeoff point signal R into G should be same. So this is how we shift a takeoff point to the left side of the block to before the block. And if we this is just the inverse of that, we can already see. So shifting of takeoff point before a block. So we have this takeoff point before the block. We need to shift this takeoff point after the block, so as to achieve some better simplification. So if we need to do that, how to do that? So if we shift this point over here, we have this effective diagram. This takeoff point is moved to here, and if we see that this before shifting, the output being measured from this takeoff point is R, which is nothing but this input at this point. So after shifting, we have this R into G as the output, but what we require is R only. So we add another block of gain 1 by G over here, so as to compensate the multiplication of this gain G, so as to get R. So the remember the main funda here is to get same output at both the takeoff points. So this is how we shift these takeoff points before and after the blocks as per our simplification and as per our calculations. So in coming to rule 6, we have shifting of the summing points. So we have this summing point over here after the block. So if we shift this summing point to before the block, we need to shift this summing point before the block so as to achieve a better simplification. How we do that? So let us see. If we are giving an input R1 over here and R2 is being given as an input to this summing point. So we have this signal over here as R1 multiplied by G, and we have minus R2 over here, thereby giving us this output of this signal as R1 into G minus R2. So if we forget this thing, if we shift this summing point to before the block, we can have this R2 over here, so R1 over here. So we will have this output as R1 minus R2 here after this summing point, and we will have this output as R1 minus R2 whole G. But what we require is output shouldn't be changed if we manipulate this thing. So how we have to compensate the G over R2? So this is how we compensate. So if we shift this takeoff point to the left side, we divide this gain 1 by G over here so as to compensate with this G multiplication over here. So this is how we shift this summing point. Remember, if we shift this, if this is a takeoff point and takeoff point being shifted to left, we have multiplication, and summing point shifted being shifted to left, we have division. And this is kind of vice versa kind of thing. And if we have shifting next shifting of summing point before a block, so if we have a summing point before a block, we need to shift this summing point after a block so as to achieve some further calculation, simplified calculation. So we can do that based on, but the main funda here is shifting of summing point is the output of this block shouldn't be changed. The output remains same. So whatever we have done based on that calculation, the output should be compensated for what is being done. So if we shift this summing point over here, the output should be same. So if we have this input as R1 and R2, the output here being R1 minus R2, which is multiplied by G, which is the output. So if we forgot about this block, if we give this R1 as input and R2 as input, so we have R1G minus R2, R1G minus R2 as output over here. But if we add a gain block, gain G, then we will get the same output as before. So we added a block of gain G in this path so as to compensate this shifting. So this is how we shift a summing point, or we shift a takeoff point based on our simplification of calculation. So we can do that. So if I will take a problem and I can better explain this. So first of all, learn these rules, then we will be moving on to these problems. Thank you guys for watching. If you are new to our channel, please do subscribe to Backbencher Studies.